Hello everyone, my name is toduyand and today I will be presenting my computer science project, 3D Face Reconstruction. In this video, I will explain why I created this project, how it works, and provide some examples of its usage. First is why did I create this? In the filming industry, CGI is commonly used to bring actors to the silver screen without their physical presence. However, CGI can be expensive and difficult to operate, making it inaccessible for small production companies and content creators. To address these issues, I created a tool that allows users to import their own faces into film as a cost-effective alternative to CGI. With the increasing use of 3D and 4D in films, these tools enable freelancers and small production companies to utilize 3D face reconstruction in their projects, in the age where the ability to design and animate is becoming a valuable skill set. Next is how my app works. My app is built in blocks as shown in the picture. First is dlib, a computer vision library that integrates many classical image processing methods as well as using deep learning techniques. The images, after going through dlib block, will return a list of coordinates where each element in the list has the form xmin, ymin, xmax, ymax, representing the bounding boxes around the face. Next, these coordinates and images will be passed to the TDDFA block to align and adjust the face, as well as detect face landmark points. I flexibly use the two sparse and dense mode of TDDFA in landmark detection. The TDDFA block has refined the face detection results from dlib by aligning the face and detecting important facial landmarks like eyes, nose, mouth, etc. With our landmark and bounding boxes, TDDFA will begin reconstruction. There are two modes for this process. First is sparse mode, visualizing 68 face landmarks for debug. Second is dense mode, creating a personalized face model requiring up to 30,000 face landmarks for accurate model. In the next part, I will explain in more detail about dlib and the mechanism of face detection that I have studied and applied in my application. dlib library, an open source library that offers various machine learning models, is very easy to use, user-friendly, and supports the initial step of receiving input images and video from webcam. Specifically, I use the frontal face detector model, which utilizes the HAWK methodology for fast and efficient face detection. If needed, the face detection approach can be changed to a more accurate method, such as CNN or DNN, although this may impact storage and speed. dlib will then return coordinates of bounding boxes that contain faces in the image, which serve as input for 3-dimension dense face alignment or TDDFA. In the last part, I will explain AI ethics in this tool. First is fairness. This tool recognizes and processes face images of any person, regardless of race, age, or genders. Second is inclusiveness. This tool aims to provide anyone 3D face model and doesn't require much CS knowledge to use. Third is privacy and security. This tool only supports local server and its data is stored on disk for entertainment purposes, which is given consent by the user, preventing face model from being stolen. Fourth is reliability and safety. Models and source code being used in development of my application are a result of reliable and open research done by face recognized researchers, specifically 300WLP, AFL W2000-3D, and Manpo3D. Fifth is open source. The source code is a combination of open source libraries such as dlib, 3DDFA version 2, Pygame. Though commercial use is permitted, my application will be free and open for anyone, and anyone can develop it in the future. In this part of the video, I will guide you to set up and run my application. First, you will need to install the tool from either cloning the repository or downloading the repository from GitHub from a button like this. I already have the folder installed on I already download the folder on my PC. So now I'm gonna unzip it in here. You would need to set up your virtual Python environment. For this, I will use Anaconda because it is efficient and easy to use. To set up a virtual environment in Anaconda, you will need to follow my steps. Anaconda, create /new. This is the name. You can change it to whatever you want. After you have done downloading the environment, you need to activate it. Activate. Okay. Once you have activated the Face project, you will need to navigate to the folder and then install the required library to run my application. Okay, once you have finished the install the required libraries, you will need to go to this folder Sim3DR to build your own Sim3DR for the application to work. Once the code is finished generating, you can now run the app. The app is named guimain.p. Okay. After finishing setting up the required library, you can now run the app by typing Python umain.p. My app is still named umain.p. You can change this to whatever you want. Okay, in our UI, there are 4 sections. Mode, which dictates the input for our application. Second is process. The process is involving creating your face in 3D. The third is saving the output, and the fourth is the notification for the error and messages. Open image is, like its name, open image from the disk to serve as an input. This time, the open camera will be opening your webcam to get the footage of your face in real time. Once you're satisfied with your face, click capture. The capture image will be a frame in the webcam, and clicking confirm will begin the face processing. The first step is to visualize 68 face landmark points on your face. The second step is visualizing the face texture that will be applied to your face model. And the last step will be visualizing your face in a 3D environment. If you are satisfied with the output, click Save, and there should be a folder in the output with its date and time, with your date and time that you click Save. Here you can open the data 3D.object file to see your face in the 3D environment. That is all for my presentation. If you have any question, please contact me through the email provided in the GitHub. Thank you for listening.